Hello, welcome to CSC7132, Operating Systems and Networking. This is Brady. Now, in the previous section, we just talked about file directories. A file directory is a special purpose file that records information about other files and possibly other directories. Now here, in section 8.3, we're going to talk about the implementation of file directories. Now, in addition to a file's name, data, and metadata, the file system, the operating system file system must keep track of various attributes necessary for accessing the file and for providing relevant information to the users. Okay, so here we have a list of the typical file attributes. The first one in the file attribute is the size of the file, the current size in bytes or words. Now, the second one is the type of file. So this provides the information to differentiate directories, regular files, executable files, and other type of files supported by the system. Okay, and also the location. Information necessary to locate the file's physical blocks on disk. Okay, and protection. The protection provides information about who can access the file and the permitted type of access. For example, for some user, you can read the file and also execute the file. And for some other user, it's read only. Okay, so you have to provide that information in the file attributes. And also the use, the date and the time of file creation, last access, and the last modifications. Okay, so these are very important information related to a file. Okay, so here's an important design issue. Where can we keep the file attributes? Okay. So one approach is to keep all attributes together with the file name inside each file directory. Okay. So you put everything in the directory entry. Now we call these the first approach, approach 1. Okay, now so here it's a directory entry. Now we put the file name here. And also all the attributes are put close to the file name in the directory entry. Okay, so now let's use a different color. Say, here's a file name. And here is the location for all the attributes. Okay. So then these are the other file directory. Okay. Now, the main drawback for this approach is that the file directories can become very long. Now, if the attributes area is very big, okay, it contains a lot of different data. Now this area could be very big, so then the directories can become very long. Okay, so when we try to search for any file, then you can actually pass through the a very big area. Okay, So that's the drawback. Now, another approach 2. Okay, so in approach 2, we keep only the file name inside the directory, okay, and provide a pointer to a separate data structure to store the file attributes. Okay, so here's the directory entry, and we only put the file names in here. So for this particular file, here's the file name. And then we don't put the attribute in the directory entry, we put in other area in the data structure. And then we provide a pointer, which is the memory address, to the attributes. Okay, so now in this case, the file names are here in the directory entry, and the attributes are located elsewhere. And then we provide a pointer pointing to the attributes. Okay, so now this, sometimes we call this is a data structure. We call it a file control block. So it's a file control block. Okay. Remember the process control block, all right? It contains all the information about the process. Now here we have a file control block. Okay. Now, this is actually a very simplified version, because now the directory entry is very simple. So the search for the file is going to be very quick, because the directory entry contains only the file name plus a pointer. Pointer takes a very small space. Okay. Now, but the performance is going to suffer, because every time when you try to find out what's the attribute for the file, and you need to go to find the file name, find the pointer, and then go to another location in the memory and find the attributes. So there's a compromise. Okay, so we call the approach 3. Now in approach 3, so again we have a directory entry, so then which contains the file name, and then we're going to put some very important attributes with the file name in the directory entry. So we call these critical attributes. And then we put the other attributes elsewhere. And also, of course, we need to provide a pointer pointing to the other attributes. Okay, so here we have a file name, and then we have a critical attributes, which is actually in the directory entry. Hopefully it doesn't take much space, so then the performance is not going to suffer. And for the rest of the attributes, we put it in the data structure elsewhere, and we provide a pointer pointing to that, the data structure. So this is a compromise. Okay, so these are all 3 different approaches. So let's talk about the internal structure of file directories. Now, the operating system file system must be able to efficiently do a couple of things. Number 1, search directories for file names. Okay, And number 2, find and allocate an entry when a new file is created. Okay, so when a new file is created, the file system must be able to find and allocate an entry. Okay. Number 3, free an entry when a file is deleted. If the file is deleted, you have to free the entry so the file system can allocate the next file. And then number 4, so change the file name, and this may shorten or lengthen the name length. Now, in order to handle this efficiently, there are several approaches to organize the directory entries. In the first approach, the directory is an array with fixed length entries. Okay, so here, let's see. So here's a directory. Now, each entry is a fixed length. Okay. Now each entry is either occupied or free. So we basically use a number, just one bit in each entry. Now, if the entry is occupied, then we use 1. And if the entry is occupied, then we use 1. Okay. And then if this is not occupied, it's free, then we use 0. And this is another occupied. Okay. That's the remaining. Okay. So each has a fixed size. Okay. Now, an occupied entry points to the file control block containing all attributes. Okay. So here we have a pointer, we have a pointer, and we have a pointer. Now this 1, because it's not occupied, right? It's 0, so it's not occupied. So then this is going to point to the file control block, which contains all the attributes, and this is going to point to its whole file control block. And file control block. Okay. So now the rest of the space, you can actually store the file name. Okay, you can store the file name. So let's use different color. So let's use the okay. So these are occupied. Okay. Now this also a bit which contains 0, so this is not occupied. And then this is a space used to store the file name. Okay, to store the file name. And this space is free. Okay, this space is free. I use the green color. Okay, so that's the simplest directory organization. Okay, now search for a file name or a hole is done by repeatedly advancing a point by the entry size. Okay. If you want to search, okay, so you can start from the first one. Okay, and then you jump the size of an array or entry. So you jump to the next one. And then you jump to the next one because each one has the same size, right? So you can keep jumping. So the search for file names or hole. So in that case, you want to search for hole. So you want to allocate the file, and then you find, here the bit contains 0. So that means, oh, it's not used. It's free. So that's a hole. So then you can actually place a new file into that location. Okay. Now, allocating or freeing an entry only requires changing one bit, because if this one is found and you want to allocate a file, then you can put the file name in that location, and then you change the bit from 0 to 1. Okay, it's pretty simple. Okay, now that's the simplest one, but it's not very flexible because the file name takes the same amount of space. Now the second approach, the directory is an array with variable length entry. Okay, so in that case, let's see. Let's see now the first one is longer, the second one is smaller, bigger, smaller, dot dot dot. Okay, now the first one entry is bigger than the second entry, right? So both are occupied. So this is 1. There's still a 1 bit to represent a 1. But then there's another space that stores the length of the entry. This one gonna stores the length of the entry. Okay. So then you have a pointer that point to the FCB, the file control block. Control. That's 1. That's the length. P. Okay. That's the space that they used to store the file name. Okay. Now, the rest of the space are free. Okay. Let's say if that's a free space, so that means it's a 0, and also the length of the free space, but there's no pointer pointing to the, there's no point in this case because it's free, right? So this space is free because the bit is, oh, that's L, the bit is 0. Okay, let me actually use different color. So let's see. So this is actually the okay. Let me see what else. That's L. The length of the hole in that case. That's occupied. Length of the entry, and that's the pointer. Okay. So each actually point to the FCB. 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 Okay. So this is occupied, so I'm gonna use this. So it's occupied. This is occupied, and this is free, right? And this is occupied. It's a very small space. So that's the directory using the array with a variable length entry. Now each entry contains a length field and either a valid file name or free. Okay. So that's the second approach. Now the third approach, the directory is an array with variable length entry, and each entry contains a valid type, file name, followed by a possibly empty hole. Okay, so each entry also contains 2 pointers, one pointing to the end of the entry, the second point to the end of the file name. Now let's see what's good about this approach. Okay, let's see. here. Oh, we forgot now the second case. Now to search for a file, you need to, okay, first start from the beginning, okay, and then you just look at the L, the length of the entry, and then the length of the entry is going to actually point you to the end of the file name. So you actually go to the next entry, and the next entry it's 1, so the length of the entry. So based on the length of the entry, you're going to actually go to the beginning of the next entry. And this is 0, that means this is a hole. Okay, you can either put entry, the new file entry in there, or if you want to continue, so then you check the L, the length. If the length is big enough to accommodate the file name, then you actually put the file entry over here. But if it's not, then you can continue search based on the L, then you can go to the next entry. So you can actually jump, but you have to look at the size, okay, the length of the entry, and then it's going to tell you what is the beginning of the next entry. Okay, so that's the second approach. Now the third approach, let's see. Okay, so we have 2 pointers, and that's the entry. So we have a K, we have a L, okay, and then we have a pointer to the FCB, and then the K basically point to the end of this, okay, entry, pointer to the end of the entry. Now the other pointer L, okay, so pointed to the end of the file name. Okay, end of the file name. Now why is that? So that means now this space is used by file name. Okay, now so this is the whole entry. This is the whole entry. But that's the end of the file name. Okay, so and that's the end of the entry. Now that's a free space. Okay, now let's take a look at the second item, second entry. So we have a K, we have L, and a K pointed to the end of the entry, right? And the L pointed to the end of the file name. Okay. So let's put these different colors. Okay, that's the point, which is pointed to the file control block, and that's the space for the name, and that's the so that's the end of the entry. That's the end of the file name. Okay. So now between the end of the file name and the end of the entry, there's a free space. Okay. And the same thing for the next one. So you have a K, you have a L, okay, and you have a pointer to the file control block, and that's the end of the file name. That's the end of the entry. So K points to the end of entry, and the L points to the end of the file name. Okay, it's a little bit messy. So let's use different color. Okay, that's a free space. Now, how can we do this? Okay, now let's check this. So when I actually search for a hole, so if we want to allocate a file in a directory, so then when I search for the hole, I start from the beginning, right? And what I'm gonna do is I check the end of the file name and the end of the entry. So K is the end of the entry, L is the end of the file name. So then I actually check the hole. So what is the hole? The hole is basically the K minus L. Okay, that gave you the length of the hole. Okay, so if the length of the hole is big enough to accommodate the file information, the file names, and also, you know, the pointer for the file control block, then you can actually allocate the file into that space. Now it looks like that's a small space. So then if it's not working, then we're gonna actually follow the end of the entry. So we actually jump to follow the K, we jump to the next entry. So the next entry, we just check the K and the L. Okay, so we just K minus L. K is the end of the entry. L is the end of the file name. So that's a free space, right? So if that free space is big enough, okay, it's big enough, that's good news. Then we can just go ahead and allocate this into, okay, into that. I have to squeeze that, file information into that space. And then, so here we can, okay, and then we can allocate the file name here, the file name. Okay, in this case, maybe the file name gonna be actually take the whole space, so there's no hole at the very end. So in that case, if there's no hole, so that means the value of K equals the value of L. K minus L equals 0. Okay, so the value of K equals the value of L. So that means K points to the end of the entry. L also points to the end of entry. So that means K and L has the same value. So that means the whole space is used for the file name. Okay, so that's a new one. So this is how you're going to allocate the new file. So you can search the whole, instead of actually check the bit, whether it's a 0 or 1, you basically do the math. Just subtract the K by L. Okay, for each entry, subtract the K by L. If the K minus L is a bigger one, so that means there's a big hole in that area. Okay, so these are basically the 3 different approaches to organize the directory entry. Okay. Okay, so let's summarize all these different approaches. The first approach, the directory is an array with fixed length entry. So the directory is an array with fixed length entry, and even the free extra entry, so the whole, it's also fixed length. Okay, so 1 basically means that this entry is occupied. This is occupied. This is occupied. Now 0 means it's free. Okay, so it's pretty simple. Finding, freeing, or allocating entry is simple, because all have the same size. So the main drawback is all file names have a maximum length. Okay, you cannot have the file name longer than the space can provide you. Okay. Now the second approach, the directory is an array of variable length entry. Each entry contains a length field, the length field L. Okay, and either a valid file name or free. Okay, so then again, we use 1 bit to represent whether this field is occupied or not. Okay, so the search is actually searching for a file name or a hole is accomplished by following the length field. Okay, so you start from here. Okay, following the length field, you reach the end of this entry, and then following the length field, reach the end of this entry. Okay, now 1 basically means occupied, 0 means empty. Now the third approach, the directory is an array with a variable length entry. Each entry contains a valid file name followed by a possibly empty hole. So here, at the end of the entry, it's an empty hole, but here, it's not empty. Here, it's not empty. Okay. So then each entry contains 2 pointers. One is pointing to the end of the entry. The second one is pointing to the end of the file name. So the hole is the difference between K and L. Okay, if K is bigger than L, then K minus L is positive number. That's the length of the hole. Okay, now in this case, the hole is small, so maybe it's useless. But if the hole is big, then you may accommodate another entry. Okay, again, K points to the end of the entry. L points to the end of the file name. In this case, the file name takes the whole space, so K minus L equals 0. Okay, in this case, again, K points to the end of the entry, L points to the end of the file name, so K minus L is this. So these are 3 approaches to deal with the file directories. Thank you.